So if the compound is pure, it contains same element which combines in a fixed ratio. You can see another few reactions. No need to bother about all of these reactions. Just focus that there are different reactions in which carbon dioxide is producing. Like if you burn a piece of coal, as I told you yesterday, you will get carbon dioxide, as you can see in the first reaction. Then if you heat limestone, calcium carbonate, you will get carbon dioxide. Okay. Similarly, another example, carbon dioxide is producing another carbon dioxide. In all of these different reactions, carbon dioxide, one carbon, two oxygen. The ratio is 1:2. Carbon dioxide 1:2. 1 ratio of carbon, 2 ratio of oxygen. Okay, so mass will remain same. Secondly, so if either you talk about in the form of number of atoms, or you talk about their masses, the thing is same. So what are the three main points regarding this law? All pure substances have constant composition. If the substance, if the thing, if the compound, if the chemical is pure, it always contains same element. Second, all samples of a pure substance contain the same elements in the same percentage or in the same ratio or in the same ratio of masses. Okay? So this is one of the most important characteristic of compound comparing with mixture. Mixtures do not have such restriction. You can mix, you can prepare a mixture in any proportion. Suppose you want to prepare a mixture of sand and water, then either you put 1 tablespoon of sand in water, in a jug of water, in a glass of water, it remains a mixture of sand and water. Okay? So that is why it's written there, mixtures do not have such fixed composition. All right? Another slide just to put weightage. Law of constant composition or law of definite proportion. Read it by yourself. A chemical has exactly the same proportion. I'm not repeating because you just explained it. Okay. So, what is next? Now the new thing is here. What is that new thing? What is that new thing? You know, I told you that each atom has masses. All right. So, for example, what is the atomic mass of hydrogen? 1. What is the atomic mass of oxygen? 16. What is the atomic mass of carbon? 12. What is the atomic mass of sodium? 23. These are called the atomic masses. Okay. So if I write here H2O, how many hydrogens do we have here? 2. What is the mass internationally accepted by scientists for this hydrogen? For one hydrogen atom, just 1. How many hydrogen do we have? 2. So what is the mass here? 1 into 2. 2 is the mass of hydrogen. What is the mass of oxygen? 16. So 16 is the mass of atomic mass of oxygen, and 2 is the mass of hydrogen. Why 2? Because they are the mass of hydrogen is 1, and here we have 2 hydrogens, so 1 to the 2. So whenever water is there, it always contains the same ratio, 2:16. 2:16, or you say 1:8. 2 on the 2 to 8 is 16. All right. This slide is your assignment. I repeat, this slide is your assignment. Go through this slide by yourself. It's not a big deal. It's very easy. I'll talk about this slide tomorrow. I just told you briefly, but not explaining, just to put some creative nature, just to enhance your creative nature, right? Carbon dioxide. See what is next? Carbon dioxide. Carbon mass 12. Oxygen. What is the mass of oxygen? 16. How many oxygens? 2. 16 twos are 32. So what is the ratio of masses of carbon and oxygen? 12 is to 32. If you want to cut it down, 4 through the 12, 4 is a 32. Okay? Remember, we are not talking about right now about their numbers. Now, what is the number here? What is the ratio of numbers? 1 carbon to oxygen. The ratio is 1:2. This is the ratio by their numbers, and this is the ratio by their weight. Difference, there is a little bit difference. All right? This is the ratio of numbers. Like, for example, look at the board. Just take this example again, H2O. How many hydrogens? 2. How many oxygen? 1. The ratio is 2:1. This is the ratio by number. But if we talk about the weight, so what is the weight of one hydrogen? 1. How many hydrogens? 2. 1 2 is 2. 2 is to 16. This is the ratio by mass. This is the ratio by mass. And this is the ratio by number. Okay? Now, how did Berzelius put his effort in this law? He heated about certain quantity of lead, 10 gram of lead with various amount of sulfur. Okay? And he always got a fixed value, 11.56. What? Suppose you want to make burgers or sandwiches rather. Okay? So you will need a fixed amount of kebabs and bread pieces. Suppose you want to make 10 sandwiches. You want to make how many sandwiches? 10 sandwiches. So someone has provided you 10 kebabs and 24 bread pieces. So you have a fixed value of kebab, 10. So how many pieces will be, bread pieces will be left behind? For each sandwich, you will need 2 bread pieces. So 20 will be consumed. How many will be left? 4. Why? Because you need a fixed amount. The number of slices, the bread slices is more. That is why it is left behind. The formula, the ingredients, the recipe of sandwiches is fixed. That is why you got surplus amount extra. Bread slices. Same is true here. What he did, he took 10 grams of lead. 10 grams of lead will require a fixed value of sulfur. Okay? But each time he got the same quantity again and again, 11.56. The surplus amount of sulfur all wasted, not used. This is a little bit confusing. Read it again and again. If not, leave a message. I will explain it again to you tomorrow.